So this question is about connected rates of change. So the volume of a sphere is decreasing at a rate of 60 millimeters cubed per second. Find the rate of decrease of the surface area when the volume is 800 millimeters cubed. If I start by breaking the question down, so the volume of a sphere, so that means I'm going to work with the volume of a sphere. So the volume of a sphere, as we know, is 4 pi r cubed over 3. And because I'm going to be looking at connected rates of change, I can differentiate that. So dv by dr straight away tells me that it's 4 pi r squared. And I know that the volume is decreasing at a rate of 60 millimeters cubed per second. So that means the rate of change of the volume is 60. So dv by dt, which tells me the rate of change of the volume. And because it's decreasing, that means it's going downwards. So it's decreasing at a rate of negative 60. Find the rate of decrease of the surface area when the volume is 800 millimeters cubed. So I'm also going to be working with this surface area. So I know that the surface area of a sphere is 4 pi r squared, which tells me that dA by dr is, bring that down, you get 8 pi r. And I'm also going to be working with the fact that the volume is 800 millimeters cubed, so V is 800. And the question is, find the rate of decrease of the surface area. So I am after what is the rate of change of the surface area, so what is dA by dt. And I can use these known facts here, here and here to work out dA by dt. So dA by dt, I can use this one to give me an A in the numerator, dA by dr. I don't want a dr at all, so I need a dr to cancel out. I can use this one here, so I'm going to have to use the reciprocal of that, dA by dv. I don't want a v in the denominator, so I need a dv in the numerator to cancel that, so I can use dv by dt, and that will leave me, the dr's will cancel, the dv's will cancel, and that will leave me with dA by dt. So dA by dr is 8 pi r, that's from there, times dr by dv, which is the reciprocal of that, so it's 1 over 4 pi r squared, times dv by dt, which is negative 60, which equals, the pi's cancel, the 8 will cancel with the 4, one of the r's will cancel there, so I'll be left with a 2 and a negative 60, so I'll get negative 120 in the numerator, an r and the r squared will cancel to leave an r in the denominator. So the rate of change of the area over time is negative 120 over r squared, which makes sense because it's decreasing. So the question is now, I need to go back and find what r is. So using the fact that the volume is 800, so V equals 800. That tells me that 4 pi r cubed over 3 is 800, which tells me that 4 pi r cubed is 2400, which tells me that pi r cubed is 600, which tells me that r cubed is 600 over pi, which tells me that r is the cube root of 600 over pi. So using the radius there, I can then go back and substitute it into my original dA by dt. So I end up with negative 120 divided by the cube root of 600 over pi. And when I type that into the calculator, I'll get an answer of negative 20.8. So looking back at the question, it says, find the rate of decrease of the surface area when the volume is 800 millimeters cubed. So we know it's going downwards, so the actual decrease, so it's decreasing at a rate of 20.8 millimeters squared per second. Thank you.